Okay, we have a rate law that is given to us right here. Okay, so it says that this rate, and it gives us an initial rate of that reaction right here, is going to equal to some constant times nitrogen monoxide raised to the second power times the concentration of oxygen. Okay, and it says here, what would the initial rate of the reaction be? So we want to recalculate this rate. It gave us that. If the concentration of NO were cut in half. Well, if it was cut in half, let's just think about this for a minute. So if it was cut in half, whatever that concentration is, then that is going to be squared. And so actually what happens when we square 1/2 is that it's going to cut that rate by 1/4. Okay, so what I need to do in this problem is to take that initial rate, and in this case, because the order of the nitrogen monoxide is second order right there, then we need to, when we do our math, cut that initial rate, divide it by 4. Okay, so let's go back into Alex. Let's pull up our calculator here. Okay, so we have here 54 divided by that 4. Okay, and so that equals 13.5. Be sure you have the correct number of sig figs, and so we do here 13.5. Okay, and then when we put 13.5 molarity per second, then that should give us the right answer, and it does. Let's go ahead and maybe we can try another one here to see if it gives us something different. Okay, and I think that it does. So let me just hurry and go ahead and copy this over and put it someplace where I can just write and think a little bit here. And so let's go ahead and create something new here, and now you can see when I did this. So let's go ahead and paste that in. Let's make it a little bit bigger here. Okay, and there we go. Okay, so here's a similar problem here. So this rate that we have a rate law here. So rate is going to be proportional to this constant here. Nitrogen is going to be raised to that first order, and hydrogen is going to be raised to that second order right there. Okay, so it gives us an initial rate here, and it says what would the initial rate of the reaction be if the concentration of N2 were halved. Okay, so it gives us that initial rate, and it's that proportional, so it's telling us, let's look at that concentration. Again, we want to cut that in half, so I'm going to do 1/2 times whatever that concentration was. Okay, and that is raised to the first power. So when I raise that to the first power, then that is going to just simply be 1/2. So because it is raised to that first order right there, then I am able to, in this case, just cut that rate in half. So let's go back to our Alex, and we have 83 divided by 2, and so that's going to equal 41.5. When I put that 41.5 in there and check that, then that should give me the right answer. So again, these are easy to do. Just remember those order, look at that order of each of the concentrations there, and just make the appropriate adjustments.